Okay, so today we're going to talk about atomic structure. Um, and this is dealing with atoms, elements, and their building blocks. So, as you remember from Unit 1, an atom is the fundamental building block of matter. So, elements, it refers to materials made up of only one type of atom. Alright, so on the periodic table, if you ever see, wow, um, if you look at the blocks on the periodic table, I'm gonna do helium. You'll notice that there's a symbol in the middle and two numbers. So on top, we have what is referred to as the atomic number. So the atomic number refers to the number of protons that is in this element. So the number of protons isn't going to change because when you change the number of protons, you change the element. So now on the bottom, this number is what is referred to as the atomic mass. So the atomic mass is the mass of the neutrons plus the protons. And then in the middle is our symbol. Every element has its own symbol. I'm not going to expect you to memorize all of them, but you should be familiar with the periodic table. We'll talk about that more when we get there, but overall, like, these things you do need to be familiar with because it is important, especially when we get into later topics. So, molecular elements are also something we have to talk about. Two or more atoms of the same element join together. Okay, so there are 7 of these on the periodic table that occur in nature. They're called diatomic elements. So I'm going to list those here. And when we get to the periodic table, I'll help you kind of label everything so you know which ones are your diatomics. But we have hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, which needs a 2 there, and iodine. So in nature, you're going to always find these as diatomic, bonded together. So other than that, there's not really too much more about the structure of elements and the periodic table and all that. We're going to start going into the modern atomic theory. And this is like some conceptual stuff that you need to know. So there's 4 steps, I believe. Yeah, 4. So I'm going to read them and then write them down. And you should copy these. It's important. So number 1, each element is composed of tiny particles called atoms. And I know this might seem kind of confusing because you're like, well, you just said atoms and elements are kind of the same thing. Yes, elements are composed of them because if I gave you a bar of gold, that's not one atom of gold. It's probably trillions of atoms of gold. So that's the idea behind an element is you can have however big it is, but if it's an element, it's going to be made up of a bunch of atoms of just that element. So each element is composed of tiny particles called atoms. All right, number 2. All atoms of the same element have the same mass and properties that distinguish them from atoms of other elements. So let's write that down. So we'll put mass Okay, so kind of elaborate. You can also refer to physical properties like boiling point, melting point, solubility properties, anything like that, electronegativity, they're all going to be the same for one element. And, certain elements are going to be similar, but there's always going to be a difference in the exact number. I mean, some might be the same. I don't know. I can't say always, but, for the most part, you're going to be able to distinguish elements from each other just based off of any sort of physical property. So, 3. Atoms combine in simple whole numbers to form compounds. So that means that they have specific ratios that they join together. I'll get into that a little later. We're not going to really touch on that today, but it is important for you to be aware. You don't say, hey, I have half of an oxygen atom. It doesn't work that way. So atoms combine in simple whole numbers to form compounds. So what that means is specific ratios. Okay, and our last one. Hopefully I can fit it in on this page. It's looking doubtful, but in a chemical change, atoms change the way they are bonded together with other atoms. And look at that, I fit it. Okay, so if you need to copy any of these, just pause the video as I'm reading them and copy them down. But I'm going to go to the next page. Okay, so the atom as we currently understand it has 3 types of subatomic particles. Okay, so I'm gonna make a little chart real quick, and it's going to detail the atomic particle, its symbol, its charge, and its mass. And all of these are super important because they will come into play throughout the rest of this course. So I think this should be long enough, but we'll see. So just copy this chart down. It'll help you organize it a little better. Okay, so first one is the proton. The proton is represented by P+. We have the electron. That is represented by E negative. And then we have the neutron, which is N0. Alright, so our charge for a proton is +1. Our charge for an electron is -1. Opposites attract. And then our neutron is a 0 charge particle. And then for our mass, our proton has a mass of 1. The electron does have a mass. I'm not going to even go there. It's so it's so small compared to the proton and neutron that we can effectively write it as 0 for the purposes of this class. But yes, it does have a small mass. And our neutron has a mass of 1. And that's, if you start taking like upper level division courses when you get to college, they'll probably tell you what the actual mass is. But even, general chemistry, they're going to just refer to it as 0. Okay, so mass is measured in atomic mass units, and later on it's also measured in grams per mole, which is a conversion factor, but we're not going to get into that right now. But anyways, so let's write that down. Mass is measured in atomic mass units. That's all we're going to worry about today. And the symbol for atomic mass units is just AMU. Okay. So, again, we're going to make a box. And then we're going to do carbon, which is 6 and 12.01. Okay. So, again, right now I want you to pause the video and see if you can fill out which one is the proton, symbol, and the mass without looking at your notes. Then I'll go over it. So, up top, we have the atomic number, which is what, if you think about it, is protons. Here is our element symbol. And on the bottom is our atomic mass, which is protons plus neutrons. Okay, so that's pretty much it for this portion. And now we're going to touch on the Bohr model of the atom, which is what you usually see when... You guys have probably already seen this when you took biology, because they use this in textbooks, I think. But anyways, I'm gonna make some circles real quick. If you need to copy this, pause the video and then copy it, and then we're gonna continue down here. So let's make... Wow, this thing doesn't want to work today. Okay, Let me make this a little easier to see. I'm gonna just do it for hydrogen. Actually no, that we're gonna just do like a generalized one that's not anything. It's just going to be a concept. This is not a specific element, because hydrogen doesn't show a certain thing that we need unless we use an isotope. Okay, so in the middle we have a proton, we have a neutron, and this is what's referred to as the nucleus. It's like the centralized area of mass for the atom. And then on the outskirts, in this little cloud area, we have our electrons, and they orbit around the nucleus. And this is like a way to visualize what an atom is. So atoms and elements on the periodic table are neutral in charge. So write that down. That is a super important concept to know. So they're neutral in charge. What that means is you have the same number of positive and negative charges. So that would mean protons equals electrons. Alright, so now knowing that, we look at a proton being +1, electron is -1. So if you can kind of see that, knowing from, I'm going to give you an example, this might help. Don't worry, I'll change that. So, let me move it down a little bit. Say we have carbon, for instance. So carbon has an atomic number of 6 and an atomic mass 12. But so that tells you right there how many protons, how many neutrons you have, because neutrons equals atomic mass minus atomic number. So we can figure out how many neutrons we have. And then using this relationship above, knowing that all elements on the periodic table and all atoms are are neutral, then if we have 6 protons for elemental carbon, that means we have 6 electrons. So remember, protons equals electrons. So if we made a little chart for carbon, we would have, let me see if I can do this. I don't know if I have room. So barely gonna have enough room. And then this is for carbon. So if we made a little chart, we have 6 protons, and because we have 6 protons, we have 6 electrons, and then we take, you can ignore the 0.01, you're not going to have 0.01 of an atom, of a proton or neutron, that's ridiculous. But anyways, we take 12 minus 6, we have 6 neutrons. So that's kind of how you can use these this atomic symbols and everything from the periodic table to figure this stuff out. It's not super difficult. It's actually very easy. But just so you know, the neutral atom means that protons equal electrons, and I'll write the symbols underneath. because I'm going to use them interchangeably. So take a second to copy that. I'm going to, pause the video, but I'm going to go on to the next page. Okay. I showed you how to do it with carbon. Now I want you to use the periodic table to figure out these 3 atoms. So I'm going to write down the example, and then I'll go over it after. I want you to pause the video and try it though. Alright, so find nitrogen, sulfur, and iron. Alright, so I'll give you the atomic numbers for each of them so you can kind of locate them better. But this one is 7, I want to say it's 16, yeah, and 26. And then take a second to work on this. Make a little chart if you need to. I'm going to make the chart and then pause. You can pause the video and we'll work on this. Okay, so if we look at, I'm going to open my periodic table on here so you can see. If it decides to open, there we go. So let's look at nitrogen. Nitrogen is number 7, and it has an atomic mass of 14. So I know that it had, just from the atomic number, I know that elemental nitrogen has 7 protons, 7 electrons. So then, to figure out the number of neutrons, I do 14 minus 7 equals 7. And then that would be the answer for nitrogen. So now we're going to do sulfur. Sulfur's number 16, it's right under oxygen. So it has an atomic number of 6, and it has an atomic mass of approximately 32. So I'm going to do, it's got 16 protons, 16 electrons. And we do 32 minus 16, which just happens to be 16. Now, I chose iron because it's common, and also because it doesn't follow this. It's just 2 times whatever the protons is for the mass. That changes depending on the element that you have. It just so happens that these 2 are equal. So, looking at iron right here, it's in your transitional metal block. If it decides to open, there we go. So, iron has a, we can round this up to 56, because it's very close. It'd be kind of, it wouldn't make sense to round it down. So, the atomic mass is 56. And it has a atomic number of 26. So we know that it has 26 protons, 26 electrons. But if you do 56 minus 26, you end up with 30. So it has 30 neutrons. So that's why it's always important to make sure, even though the math is super simple, make sure you do it, because otherwise it's not going to make sense. And I have one more thing that we're going to touch on today. And then this should pretty much do it for the basic atomic structure. Alright, so I know you've probably heard the word isotope, but do you know what it means? So I'm going to write down a definition for you. So an isotope it's an element, but the number of neutrons varies. That means it's different. So it's the same atom, same element, different number of neutrons. So another way to think about it is same element, different number of neutrons. Alright, so I'm going to show you how to write this down with the symbol and kind of explain what it means, because it is a little different than from the periodic table, but it's not hard. And we're going to, go over something that I really, really want you to get ingrained. So remember, protons identify the element. Think of the protons as the element's Twitter handle or whatever. That is what identifies it. You change the protons, you change the element. Okay, so isotope symbol. I'm gonna just show you. It's written like this. So let's label everything. The X just means it's the element symbol. What the heck is going on with this? Let me close this out. Maybe that's it. Anyways. So that's the element symbol. On the bottom now is the atomic number. And wait, I think that one was blue on the other one. Let's just make it blue. And on the top is the atomic mass. So you can write elemental, the elemental form of the element from the periodic table. You can write that in isotope notation, but it's generally not done. But if you're comparing things, that's how you do it. So anyways, I'm running out of room here, so I'm going to go to one more page because I don't want to have to squeeze all this in. But just copy this down, pause the video. I'm going to go to the next page. And then we're going to go over something super, super simple, just isotopes of hydrogen. So let's write down, we have, let me label this. So we have this. We have 2H1 and 3H1. Okay, so I'm gonna make like little table, not even a table. I'm just gonna write protons, electrons, neutrons. So remember, the atomic number's on the bottom. The number of electrons isn't changing. That's something else. That's ions. We haven't talked about that yet. So the protons is always 1 for hydrogen. So proton is like, it doesn't change. The electrons is 1, 2. The only thing changing is the mass and the amount of neutrons, not the protons. So if you look at, this is hydrogen from the periodic table. 1 minus 1, because you have atomic mass minus atomic number. 1 minus 1 is 0. So it does, hydrogen doesn't have any neutrons, but its isotopes do. So 2 minus 1, this one has 2 neutrons. And then 3 minus 1 has 2 neutrons. And that's how you're able to determine if you have an isotope, how many neutrons you have. You just have to know how to write it. It's not hard at all. But if you have any questions about this, feel free to ask me. I'm going to clean this up a little bit, but yeah, if you have any questions about this, please ask me. I don't want anybody confused on this because it's not something you should have any trouble with. And that's it for this video.